Here we are going to discuss about the cardinality relations of using union of two sets. Here I am not going to show the proof, but I am going to say the formula only. So the if A and B are two overlapping sets in a universal set U, then n of A union B is equal to n of A plus n of B minus n of A intersection B. So this is our formula. Now some more relations are here. If A and B are two disjoint sets, then n of A union B is equal to n of A plus n of B. So in Venn diagram we can use like this. Say this rectangle represents universal set, say U, and these A and B are two overlapping, means they have got a common element, at least a common element. So now look here, these two circles represent A and B respectively, and let this circle be A and another circle as B set. Now here this part is known as the intersection part, that is n of A intersection B, and this one is the n naught of A, this one is the n naught of B, and this part remains n of A union B complement, n of A union B complement. So overlapping means having both common elements on the both sets. But in the disjoint sets we know that they have no common elements. So let this is A, this one is B, and this is the universal set. So now there is no common, that is the n of A intersection B is equal to 0. So here is the another n of A and B are the two disjoint sets, then n of A union B is equal to n of A plus n of B, and there are other relations too. Let us see one by one. N of A intersection B is equal to n of A plus n of B minus n of A union B. N of A union B can also be written as n naught of A, means only A, n naught of B, that is only B, and plus n of A intersection B, n of A intersection B. So this is the another relation of A union, n of A union B, and n of only A can be written as n of A difference n of A intersection B. n of only b can be written as n of b minus n of a intersection b, isn't it? N of a union complement can be written as n of u difference n of a union b. Now here we are going to solve one question. Let us take the one question. Here is one question. N of a is equal to 65, n of b is equal to 80, and a is subset of b. A is subset of b, and then we have to find these four. N of a union b, another, n a intersection b, a difference b, n of b difference a. Now here look by figure. Now suppose this is b, set b, and the another is the set a. Since it is, and this one is called the a is subset of b, that is all elements in a contain in b. So now let us solve it by this figure here, or say since a is subset of b, so we can write a intersection b as a intersection b as a intersection b as a union b as b, this whole. Now let us look one by one. N of a union b is equal to a union b is equal to n of b is equal to, and what is the b? N of b is given as now, and it is 80. Now the second one is n of a intersection b is equal to n of a is equal to 65, and the third one is n of a difference b is equal to n of a minus n of a intersection b is equal to n of a is equal to 65, and the fourth one is n of b difference a is equal to n of here n of a minus n of a intersection b is n of a. So here 65 minus 65 is equal to 0, and b minus n of a intersection b is equal to n of b is 80, and minus n of a intersection b is what? 65 is equal to 15. So this is your solution.